All right, everyone, I just wanted to give a really quick example of calculating the drag force on an object because we didn't really do any examples with numbers in class. In this case, what we have is a pipe across a river, which you can imagine is a fairly common setup in this world. What do we know? We know the diameter of the pipe. We know how far the section of the river that it needs to go across is. We know the velocity of the water, and we know the temperature of the water, which means we can look up the density and the viscosity. We're supposed to do drag force. I am going to begin by drawing a little picture. Here we have the river. It is 30 meters across, but we will call that L, and the pipe has some diameter D, and then the water is flowing sort of crossways like that with the velocity U, things we know from our problem statement. D is 0.022 meters, L is 30 meters, U is 4 meters per second. And then, of course, we have our properties. All right. So we know we want the drag force, which means that we know we will be working towards solving this expression right here. Okay, we know every part of this, especially since we know that A is simply equal to L times D, right? Because that's the projected area of the pipe. But we need the drag coefficient. Now, it is actually a safe bet just to assume that we have turbulent flow at sort of a middle to large sized Reynolds number and just choose the drag coefficient that goes with that. But we're actually going to calculate the Reynolds number in this case. Rho U. Okay, so Reynolds number is rho U d over mu, as it ever was. And we get a Reynolds number, if you plug all of that in, of 7.73 times 10 to the fourth, which is comfortably in between 10 to the second and about 10 to the fifth, which is where we said we could use the drag coefficient that I gave you for the a simple cylinder shape in class, which is 1.18. Okay, so this is that's a reasonably good approximation of the drag coefficient for this shape. Again, it's an approximation. And so now we can return to our equation. And we can plug everything in. And for area, I'm going to plug in L times D. So that's 30 meters, 0.022 meters. Okay. I plug that in, everyone is happy and good. And at that point, we get about 6,225 newtons. And just to help your intuition along a little bit, I went ahead and converted that into pounds, and it's about 1,400 pounds force. Okay, so that's a pretty substantial force, right? Yes, yes it is. Imagine a whole 1,400 pounds on you, which is why we have to make sure that that pipe set into that river is nice and strong so it doesn't get snapped off and pulled down in the current and ruin everything. Anyway, there you go, a simple example of calculating drag force.